All right, today we're going to be talking about section 2.1. The whole section is called Transforming Linear Functions. And although we are going to get into transformations a little bit in this unit, we're not going to do that today. So today we're just going to be talking about graphing linear functions. So let's go to work. So we should be looking at section 2.1. You should have already read and highlighted this. If you didn't, you're behind. Okay. I'm only going to talk about the first couple pages today. Okay. When it comes to page 62, there, and it starts talking about transformations. I'll talk about that on Monday. Okay. I'm not going to deal with any transformations today. Therefore, your homework today is only going to be half of the homework, like only half of the even totally. Okay. And I hope that this is a little bit of review for you, but if it's not, it's no big deal. We'll teach it like you've never seen it before. Okay. First of all, we're going to be transforming linear functions, but before that, we're going to graph linear functions. Okay. We're going to graph linear functions. Before we get too far, what does it mean to be linear? Come on. We should know this. What does it mean to be linear? Yes, sir. Okay, it's a straight line. It's a straight line with a constant rate of change. Okay? It does pass the vertical line test because it is a function. Okay, but I want one more thing, and this is where everybody gets the fact that it has a straight line because it's called linear. But what's the other part of it that's just as important that everybody always misses? Anybody? It's an equation to the first degree. I don't even care if you put equation. Just put first degree. First degree. And then the last thing I'm going to give you now, like later we're going to get a bunch of these things, but right now I want you to have y equals mx plus b. That is called slope intercept form. You need to be able to give me that in your sleep. How many remember dealing with that last year and maybe even the year before? Yes? Good. All right. We've already talked about it in class here today. Matter of fact, I'm going to come up here. I'm going to write it up here too. Y equals mx plus b. And let's talk about each part. The y is obviously the output. The x is the input. Okay, we get to choose whatever input we want. And then we plug it in and we'll get some output. But this m is the rate of change or the slope. And then the b is the initial value or the y-intercept. It's so easy when you look at one to find those things. Okay, literally can just look at it. Okay, for example number 1. What is my slope or rate of change? 2. Now, what does that mean? It means 2 over 1. Why do we like to write it as a fraction? Because remember that slope or rate of change is always the rise over the run, or the change in the y over the change in the x, right? The rise and the run. So we like it to be a fraction. Even if it's a whole number, we like to write it as a fraction because then you know your rise and your run. And then what is my initial value? -1. Remember, the sign goes with it. Okay, the sign goes with it. So this is my initial value or my y-intercept. Okay. Now, sometimes equations aren't always given to us in slope-intercept form. Like 2x plus y equals 7. So the first thing that we always want to do when we're dealing with these linears right now, if we're going to graph them, is we want to get the y alone. Okay, we want to get the y alone. I'm going to do that real quick here. I go minus 2x. So I have y equals negative 2x plus 7. Yes? So the very first thing we're going to want to do is get that y alone. Once we have the y alone, where do we start to graph this? Did you hear what I said? Where do we start? Where do we start? Say it a little louder. Where do we start? The initial value. Hey, have we already said that today? You said start. I said, hey, that's really cool because it's the initial value. Where do we start? In this case, we would start at the 7. Okay? And what would we do with that 7? We would graph it on our y-axis, right? We start at the initial value. We graph that point. Then what? Okay? We do that slope thing. In this case, we would go down 2 and over 1. This looking familiar? Okay. Now, there's a lot of examples there in the reading. Let's get to one. I think I'm next. Yep. Come on, buddy. What are you doing to me here? It's like the third time this has happened this morning. I don't like that, but at least that's staying. Good. Good. All right. First thing, Kaya. What's the first thing we need to do?
Find the initial value.
Nope. Before that. Get the y alone. Okay, then we're going to start on B. What's B? The initial value. Got it? And we're going to do the slope thing. Okay, so in this case, we're going, the y is already alone, so I'm good. Start on B. What is B? Negative 1. Now do the slope thing. What is the slope? 2 over 1, so I'm going to go up 2, 1, 2, over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2, over 1. Boom. There's my line. Cool? What if I have this one? 3x plus y equals 2. I'd like you to do that one, please. Quickly, 30 seconds. All right, subtract 3x from both sides. Y equals, can I put that 3 and that 2 together?
No.
Why not?
There's a variable.
One has a variable, the other one does not. So I just write them down beside each other. Negative 3x plus 2. Now start on B. What's B? 2. Now do the slope thing. Down 3, 1, 2, 3, over 1. Down 3, over 1. Now, 3 could be written as a negative 3 over 1, correct? Could it be written like this? Could it be 3 over a negative 1?
No.
Why not?
Because then you'd be going up 1 or up 3, left 1.
Up 3, 1, 2, 3, left 1. Up 3, 1, 2, 3, left 1. Oh, wait a minute. That's the same line. So yes, I can do this. It doesn't matter where your negative sign is, if it's on the top or the bottom. It just matters that you only have one negative sign. Just like this. Say I give you y equals 2/3 x plus 4. First of all, is the y alone? Yes, so I'm good. Start on b. What's b? 4. What's my slope? 2/3. So up 2 over 3. Up 2 over 3. Are you with me? But isn't 2/3 the same thing as -2 over -3? A negative divided by a negative is a positive, right? So I could go down 2 and left 3, down 2 and left 3, and that's the same thing, isn't it? Cool. You've graphed lines before? Okay. Your homework is this, and only this. Okay. Numbers 1 through 18, or 2 through 18, evens only. That's 9 problems. Graph it. All you got to do is graph them. Is that clear? I got one more thing to share with you, and we'll be good. You can start on that. You have a few minutes. You got like 7 minutes before it's time to go. You can start on that right now.